Okay, and now comes chapter 11. So there were a few things in chapter 11 that I was looking forward to reviewing with you guys. One of them is 11.1, probability of a single event. We are looking for events that are mutually exclusive out of a list of things. So mutually exclusive means that they will, they share something. Okay, so I have 10 fruit in my kitchen. I have 1 red apple, 5 red strawberries, 2 orange oranges, and 2 yellow lemons. So what we're looking for here are things that actually share with this, because not mutually exclusive just simply means they don't have anything in common. Okay, so if I look at this, I would say yellow or an apple. Well, I can pick either 2 yellow lemons or 1 red apple. They don't share anything here, so I'm good. So I have got my next one, so that's not it. So that's not mutually exclusive. Now I have red or a strawberry. So if you look, I have 1 red apple and I have 5 red strawberries. So this actually is mutually exclusive because I have a chance of drawing a red fruit that is a strawberry. So what this is saying is I need things. Mutually exclusive means that they both share characteristics that are listed above. So because it's not a red apple and like pink strawberries, I have to pick, like if I pick a red apple, yeah, I have 1 out of 6 chance of that, but I also have the possibility of picking red strawberries. And then strawberries is also the second thing I could possibly pick there. Okay, so move over. So over here, what is the chance that I could draw something that is orange or a lemon? Well, my oranges are orange and my lemons are yellow, so they don't share anything. So those are not mutually exclusive. Whereas down here, chance of drawing something that's yellow or a lemon, those are mutually exclusive because lemons share the color yellow. So if they share something, they're mutually exclusive. If they don't share something, they're not mutually exclusive. Okay, and then down here I have 11.2, which is probabilities of multiple events. So independent events do not influence each other. Independent events mean that they're very independent. I don't need them to, they're not going to affect each other. So independent events are when I tell you to do your classwork independently. So I say, sit at your table, do it by yourself. That's independent. Your messing up 2 times 4 is not going to mess up your neighbor's 2 times 4 unless you guys are cheating off of each other and not doing what you're supposed to be doing, in which case that's not an independent event. But in this case, we're going to assume you are doing this independently, in which case 2 times 4, you may accidentally mess up and say, oh, it's 6, whereas your neighbor gets it as 8. That's independent. You and your neighbor don't have anything to do with each other at that point. Whereas dependent events would be if I give you a group project and I say, okay, your table is set on building a Jenga tower. That's dependent. You are dependent on the people around you, so you do influence each other. If you're having a bad day and you get mad and you smack the Jenga piece out of your neighbor's hand and it knocks your entire tower over, well, guess what? You and your neighbor are dependent on each other. So that is a dependent event. You do have influence over each other in those events, whereas independent events, you do not. And then down here, I have some probability equations for us, just in case we need to know these. So I've got my 4 different probabilities. You can see I've got 2 ORs and 2 A's. So if it's the probability of, let's go back to the fruit thing, picking an apple or an orange. Well, my probabilities picking is just adding them next to each other. So picking a apple or an orange. Whereas down here, this OR is picking an apple or a red fruit. I would have to say, okay, cool, my chances of picking an apple were 1 out of 10 and my chances of picking a red fruit were 6 out of 10, but I have to cancel out the overlap. So this is my overlap right here. That's what this is. Otherwise known as shared data. So anything that they share. Okay, so this would be like, what are the chances if I put all our names in a hat that I would pick my Kyria's name or a girl's name? Well, my Kyria is a girl, so my Kyria would be 1, girls would be 2 because we have Natalie and my Kyria, whereas I can't have that overlap because my Kyria overlaps in both those data, so I would have to remove the 1 for her being the overlap there. So it would be my Kyria or Natalie. Okay, whereas here, if I were to say, what are the chances that I would pick my Kyria or a boy. There's no overlap there because my carrier is a girl, so I could just add them without having to worry about taking out any overlap. And down here are what are the probabilities of these two things happening. So this one's with replacement because you can see there's no weird line here. And this one is without replacement. So this one means I'm not putting it back in. So this is like saying, what are the chances that I would draw a red and a green marble with replacement? You'd then multiply these. So if you will notice, the ors end up being plus signs and the ands end up being multiplication. And then this is just simply with replacement, and this one is without replacement. So picking a red and blue marble, or picking a red marble and then a blue marble without replacement. So I would have to take into account for this second one here that I already took a marble out. So while I may be picking a different color, I have less marbles in there. So it changes the probability of things. So make sure that you are looking over these. Make sure you remember independent events don't influence, dependent events do. And then make sure that you pay attention to the fact that mutually exclusive means they have something shared, something in common. Okay, tomorrow we'll finish up chapter 11, and then Friday we will do chapter 12. Chapter 12 should be pretty quick here. Okay, see you tomorrow.